So in about 1805, Gay Lussac and Avogadro both put their heads kind of on the similar problem in different parts of the world. So what their idea was is that every time they do this experiment where they put in 2 volumes of hydrogen, 1 volume of oxygen, they get 2 volumes of water vapor. Now, the thing is, they came to this conclusion also knowing this. Each one of these containers had the same temperature, they had the same volume, and they had the same pressure. Now, Avogadro's hypothesis said, well, then they must have the same amount, especially if we go back to thinking about our gas laws and all the proportional reasoning that's happening in there. So they had a problem. They had a puzzle to solve. So they have to think that each box has the same amount of particles in them. So if I were drawing up here, they would have the same amount in each. And they also knew that they had to obey the law of conservation of mass. So we also have to remember that water is H2O. So that's what they discovered around this time too, is the correct composition of water, which is 2 hydrogens are attached to 1 oxygen. Okay. So what do we mean by particle? So when we say particle, when we're thinking about an amount, we're thinking about the amount of particles within a container. So a particle can be 1 thing stuck together, 2, 3, 4, it doesn't matter. It could be a lot of different things stuck to 1 thing. All that it means is that a particle is a small portion of matter. It's a part of something. So that also means that some elements and some particles can come in pairs. We call those diatomics. So a diatomic is just a molecule that is made of 2 atoms. And there are some elements that also come in pairs. So they're never found in nature by themselves. They come in a pair, and we call those diatomic elements. So if you were modeling them, they're 2 of the same elements stuck together. So if we go back to our model and we realize that hydrogen and oxygen are both diatomic elements, this is what our model should look like. Oxygen is paired up. Hydrogen is paired up. We have 12 hydrogens. We have 12 hydrogens. We have 6 oxygens. We have 6 oxygens. I have 3 particles in this box. 3, 3, and 3. Everything makes sense. So what other elements are also diatomic? Well, if we look at our periodic table, and this is the first time we've really had a chance to look at it, we can kind of start to see some patterns. So hydrogen is definitely a diatomic element. So follow along and color in your own periodic table so that way we can make sure that we have a similar language that we're speaking. Nitrogen is also a diatomic. Oxygen, like we found out earlier, that is also a diatomic. Fluorine. And now we're going to take a downturn. We're going to go down chlorine, bromine, and iodine. I tend to call this a bracket. So it kind of looks like a small little like bracket or the number 7 in the corner here. So that way we see this pattern. So it's a visual pattern, right? So there's hydrogen way over here by itself in Lonesome Island. And then over here, if you make the number 7, you can do it as long as you start with nitrogen, oxygen, and fluorine and then go down. There's also a mnemonic to remember it if you would like. And it's have no fear of iced cold brew. So we're New Englanders here, so we tend to like to drink iced coffee with a little extra caffeine. We don't have to be afraid of that. So H is for hydrogen, N is for nitrogen, F is for fluorine, O is for oxygen, I is for iodine, C is for chlorine, and B is for bromine. So those are our diatomics. So sometimes elements are found in pairs. And that's an important concept that we'll need to remember further on down through our next few units. But for right now, It's a huge concept. We've now discovered that this is why when I put in 2 volumes of hydrogen, 1 volume of oxygen, I come out with 2 volumes of water. And we'll look at some other equations that also do this too. So the first thing you need to do when you look at any equation like this, so any chemical equation, I'm adding in elements and getting out something on the other side, we have to remember that some come in pairs. So identify which ones are diatomic elements first.